Now I am discussing this problem. The problem is 2.8 into 10 power minus 3 moles of CO2 is left after removing 10 power 21 molecules from its X milligram sample. The mass of CO2 taken initially is. The options given 150.4 milligrams, 196.2 milligrams, 48.2 milligrams and 98.3 milligrams. Here X milligrams sample of CO2. X milligrams sample of CO2 was taken. CO2, carbon dioxide. The mass of carbon dioxide initially taken is X milligrams. In this X milligrams sample of CO2, 10 power 21 molecules are removed. In this X milligrams sample of CO2, in this X milligrams sample of CO2, 10 power 21 molecules are removed. After removing 10 power 21 molecules from X milligrams of CO2, 2.8 into 10 power minus 3 moles of CO2 is left. After removing how many molecules here? 10 power 21 molecules. 10 power 21 molecules removed from X milligrams sample of CO2. Then here how many moles left? 2.8 into 10 power minus 3 moles of CO2 left. Initially the mass of CO2 is X milligrams. From this X milligrams of CO2, 10 power 21 molecules are removed. Then the remaining number of moles of CO2 is 2.8 into 10 power minus. This is the problem. We have to find the mass of CO2 which was taken initially. That is, we have to find X. Given data in this problem is, first one, mass of CO2. Mass of CO2 which was taken initially is X milligrams. This X milligrams of CO2 converted into grams. That is X into 10 power minus 3 grams. Mass of CO2 which was taken initially is X into 10 power minus 3 grams. Next one, number of molecules removed from X milligrams of CO2 is 10 power 21. 10 power 21 molecules are removed from X milligrams of CO2. Next, number of moles of CO2 left after removing 10 power 21 molecules. That is given 2.8 into 10 power minus 3 moles. Number of moles of CO2 left after removing. Now we should calculate the value of X. That means mass of CO2 which was taken initially. That is X milligrams. Initial mass of CO2 is X milligrams. Now we have to find the value of X. Initial mass of CO2 given is X milligrams. X milligrams is equal to X into 10 power minus 3 grams. Now this initial mass we should convert into initial number of moles. initial number of moles. Number of moles is equal to given mass by gram molecular mass. Number of moles is equal to given mass by gram molecular mass. Given mass is equal to x into 10 power minus 3 grams, and gram molecular mass of CO2 is 44 grams. So initial number of moles of CO2 is x into 10 power minus 3 by 44. Initial mass, here we converted into initial number of moles. Number of molecules removed from x milligrams of CO2 is 10 power 21. This number of molecules removed, we have to convert into number of moles removed. Number of moles removed from x milligrams of CO2. From x milligrams of CO2 is equal to number of molecules removed by Avogadro number. Number of moles removed from x milligram CO2 is equal to number of molecules removed by Avogadro number. Here number of molecules removed from x milligram CO2 is 10 power 21 by Avogadro number is 6.023 into 10 power 23. So number of molecules removed, here we converted into number of moles removed. Number of moles left after removing 10 power 21 molecules is given 2.8 into 10 power minus 3. But this number of moles left is equal to initial number of moles minus number of moles removed. Number of moles left is equal to initial number of moles minus number of moles removed. Here number of moles left given is 2.8 into 10 power minus 3 is equal to initial number of moles, already we calculated, x into 10 power minus 3 by 44 minus number of moles removed also calculated, that is 10 power 21 by 6.023 into 10 power 23. So by solving this equation we get x. X is equal to 196.2 milligrams. Here x is the initial mass of CO2. X is equal to initial mass of CO2, that is 196.2 milligrams or 196.2 into 10 power minus 3 grams. That is equal to 0.1962 grams. Let's check the solution once. 2.8 into 10 power minus 3 is equal to x into 10 power minus 3 by 44 minus 10 power 21 by 6.023 into 10 power 23. 2.8 into 10 power minus 3 is equal to x into 10 power minus 3 by 44 minus, here 10 power 21 is there, here 10 power 23 is there. If we cancel, then we get 10 power minus 2. 10 power minus 2 by 6.023. That implies 2.8 into 10 power minus 3 is equal to, here I am taking 10 power minus 2 as common factor. 10 power minus 2 into here x into 10 power minus 1 by 44. 10 power minus 2 I am taking as common. Then we get here 10 power minus 1. Minus 1 by 6.023. That implies 2.8 into 10 power minus 3. I am writing as 10 power minus 2 into 10 power minus 1 is equal to 10 power minus 2 into x by 440 minus 1 by 6.023. 10 power minus 2, 10 power minus 2 cancel. 2.8 into 10 power minus 1 means 2.8 by 10 is equal to x by 440 minus 1 by 6.023. That implies 2.8 by 10 means 0.28 is equal to x by 440 minus 1 by 6.023. That implies x by 440 is equal to 0.28 plus 1 by 6.023. Here I am doing LCM 6.023. 0.28 into 6.023. Then we get 1.6856 plus 1. That implies x by 440 is equal to 2.6856. 2.6856 by 6.023. That implies x by 440 is equal to, if we do this division, then we get 0.446. 0.446. That implies x is equal to 0.446 into 440. If we multiply, then we get 196.2 milligrams. Here x is the initial mass of the CO2.